Alright, family, you are warmly welcome once again, and we are here to expose you to the other aspect in mathematics, which is called finding the root of whole numbers. That is, finding the root of these whole numbers without using a calculator. Alright, so before that, I would like to expose you to the idea and what we call perfect squares. Now have it in mind that before we will be able to find the root of this 98, this whole number 98, the root of the number 16, the root of the number 1764, and the root of the number 488, we should have an idea about something in mathematics, and that thing is termed as perfect squares. Are you with me? Perfect squares. Now, let me give you a gist of perfect squares so that from there you will be able to move in line with me. Very good. Now, come closer and let me show you something. I'm talking about perfect squares. Now, in mathematics, you see, we have different kinds of numbers in mathematics with their names. We have whole numbers, we have natural numbers, we have even numbers, we have odd numbers, prime numbers, we have um, 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 natural numbers, and so on and so forth. Are you with me? Very good. So over here, there are some numbers too that we call them perfect numbers. Are you with me? Now all these numbers that I made mention of, the even numbers, the whole numbers, and the rest, they all have different characteristics. They have a unique feature. That is why we term them as what? Whole numbers. If we have set of numbers and we call those set of numbers as even numbers, it means they have specific features. They have peculiar characteristics. That's why we term them as even numbers. In the same manner with odd numbers, they have peculiar characteristics. In the same manner for even numbers, they also have same. And for whole numbers, they also have same. For natural numbers, they also have same, and so on and so forth. Very good. In the same manner, when we come to perfect squares, they also have what? Unique characteristics. So we are going to look at those unique characteristics. Please listen attentively. It is not all the numbers in mathematics that are termed as what? Perfect squares. Are you with me? And you can bear with me that it is not all the numbers in math that are termed as what? Even numbers. Are you with me? Very good. So let's look at why and when do we say that a number is a perfect square. Come closer and let's see something here. All right. So now, when and why do we say that a number is a perfect square? One, let's take note of this. Before we can classify a number as a perfect square, one, the number should have two products. The number should have two products, with which when we multiply these elements, are you getting me? The number should have two elements as its product. And when we take these two elements and we multiply, we have to get a number. Now have it in mind that these elements should be of the same identity. So let's take it for instance. If I have a number 1, this number 1 should have two elements. So I can have element 1, element 2. Are you with me? Now if I multiply these elements, that is 1 times, so I'm going to get this. This is the number that I am having. So I'm getting 1. Are you with me? So over here we can say that 1 is a perfect square. Why? Because these are the elements and the elements are of the same identity. Are you with me? So because the identity 1 and identity 2, they are the same. That is why we say that 1 is a perfect square. Are you with me? Very good. So 1 can be a perfect square. Now let's go to the number 2 and see whether it is a perfect square. Do we have any two numbers that when we multiply you get 2? Yes, we can get 1 and then what? 2. When we multiply 1 times 2, we are going to get what? 2. Now ask yourself, we said that before we can classify a number as a perfect square, it means that the constituent or the element that then the element the number produces as its product. So this number produces two elements that when we multiply we will get this number back. Now let's check the elements here, whether they are of the same identity. The element 1 and element 2, they are not of the same identity, so therefore 2 is not a perfect square. Are you with me? Very good. So now let's go to the next number 3. In the same manner, for the number 3, we have 1 and 3. Though when we multiply 1 times 3, we are going to get 3. But 3 is not a perfect square. Why? Because the elements, this and this, are not the same. Let's take the next number, which is 4. So 4, I have two elements, and if I multiply, I will get 4. So I will have 2 and then what? 2. Now 2 times 2 gives me 4. Because the element that I am picking, this and this, they are of the same identity. The element this and this are of the same identity. Then it means that 4 is a perfect square. Now from there you can guess of other numbers that can be a perfect square based on the brief or the gist that I've given to you so far. We can guess of the number 9. 9, I have 3 and 3. These elements are of the same identity, so 9 is a perfect square. Are you with me? You can guess of the number, what number? 16. That we have 4 and then 4. This and this, they are of the same identity, so therefore 16 is a perfect square. Are you with me? Very good. Now to paraphrase everything, for you to understand it more, okay, we are trying to say that for you to get any perfect square in mathematics, just take the natural numbers in mathematics and square them. Are you getting me? Now I did this because I wanted to explain to you why we are classifying 1 as a perfect square, 4 as a perfect square, 9 as a perfect square, 16 and so on as a perfect square, but not 2, 3, 5 and so on. Are you with me? Very good. So remember I said something earlier that 1 is a perfect square because when we find two numbers that when you multiply, that will give us 1. We had 1 and then 1. Now these two elements, when you multiply, you get 1. But have it in mind that because this element and this element are of the same identity, that is why we are terming 1 here as a perfect square, as compared to this, as compared to this, and as compared to that. Are you with me? Very good. So now let's see what I said afterwards. I said that before you can continue with the rest of the perfect squares, just take the natural numbers and square them. So let's see something here. So we said that in mathematics, natural numbers start from what? 1 up to infinity. Whole numbers start from 0 up to infinity. So here we are dealing with the natural numbers. So natural numbers start from 1, 2, and so on. So 1 squared is 1 times 1. And this gives me what? 1. Are you with me? So 1 is a perfect square. 2 of 2, giving me 2 times 2, which gives me what? 4. So 4 is a perfect square. 3 squared, I have 3 times 3, which gives me what? 9. So 9 is a perfect square. Are you with me? Good. So we have the next number 2, 4 squared, which is 4 times 4. Well, I'm going to get what? 16. So 16 is a perfect square. So all the numbers here are all examples of what? Perfect squares. I believe it is clear. Very good. So let's continue with the next process. Now I have 5 squared. Well, I'm going to get 5 times 5, which is giving me what? 25. So 25 is a perfect square. I have 6 squared, which is 6 times 6. I'm going to get what? 36. So 36 is a perfect square. Now I have 7 squared. Well, I'm going to get 7 times 7. Well, I'm going to get what? 49. So that means 49 is a perfect square. I can also have a squared, which is 8 times 8, giving me what? 64. Meaning 64 is a perfect square. I believe it is clear. It is a perfect square because now look at it. We said the constituent should be of the same identity. The constituent, they are of the same identity. They are of the same identity. That is why we are saying that this is a perfect square, or these are perfect square. There are more. In the same manner, when you take 9 squared will give you what? 81. 10 squared will give you 100, and so on and so forth. Are you with me? Very good. So now, I believe you understand perfect squares now. So we are going to employ the ideas of, or the idea under perfect squares, or the idea with respect to perfect squares, to solve these problems. I believe you are good. So let's start and solve it one after the other. Alright, so let's continue with life. Now I'm going to solve question number 1 and question number 3 with you. Then the rest, I believe you'll be able to solve it on your own. Very good. So now let's solve question number 1. Before that, let me list down my examples of perfect squares here, because I'm going to use them a lot. Good. So examples of perfect squares. So with the examples of perfect squares, we made mention of 1, 4, 9. We made mention of 16. We also made mention of what? 25. We made mention of what? 36. We made mention of 49. We made mention of what other number? L. 64. We made mention of 81, 100, and so on and so forth. So we are going to use any of them to solve one of these questions. So let's pick question number 1. As I have my solution over here. Question number 1. I've been asked to find the root of the number 98. So let's see how to solve it using the idea of perfect squares here. Very good. So let's continue with life. Now over here, what it means that I have to get 2 numbers or 3 numbers that when I multiply, I'll get 98. But have it in mind that one of the numbers should be a perfect square. Are you good? Good. So let's pick one of these numbers and use it to check. In the first place, let me pick, we can use 1, but have it in mind that 1 times 98 is still the same as 98. So let's ignore the 1 and use 4. So with the help of 4 can help me to do that. Now with 4, expanding this or splitting this one up, I'm going to check 4 times what number will give me this. 4 times what number will give me 98. So with the help of the long division table, I'm going to get 98 here. With the help of long division, so I have my 4. 94 goes into 9 how many times? 2 times. So I have 2 here. It goes into it 2 times. So I have 2 here. 4 times that, I'm going to get 8. Remainder of what? 1. So we are checking. Is it possible that, so remember when we add b to it, 4 cannot, there will be a remainder, so 4 will not work. I would mean very good. So let's pick the next perfect square. 4 will not work. So let's pick the 9 and see if it will work. Do we have any number times 9 that will give us 98? No, it is not possible. We don't have any number there like that. What about the 16? Any number times 16 that will give us 98? Do you have any number times 16 that will give us 98? So is it possible? Any number times 16 that will give us 98. That will give us 98. All right. So the 92 won't work, and the 16, I believe the 16 will work for us. Can we dive into that and check if it will work? Okay, so let's see something here. Do you have any number times 16 that will give us 98? Let me check it and see. Let me divide the 98 by the 16 and see how it is going to work for us. Good. So over here, when we pick the number 2 to reduce that, 2 can cancel the whole of this as 49, right? Good. And 2 can cancel the whole of this as 8, and it means it is not possible. Are you with me? we are going to get 49 over 8. We can't reduce it further, so 16 cannot work. So let's pick another number. 25 cannot do that. What about 36? 36, can 36 do that? Do we have any number times that will give us that? 36 cannot do that. Can we decompose the number 98 using one of these perfect squares? Yes, so 36 will not work. So now the 49 can work for us, right? So let's pick 49. 49 as a perfect square. 49 times what number will give us 98? So now we realize that 49 times 2. Let's check it and see. 2, 9, 18. Remember 1. So 2 times 4 gives us what? 8 plus 1, which is 98. Meaning that 49 times that is. So remember the 49 is a perfect square because it's part of this. Are you getting me? I said that you get two numbers and when you multiply, you will get what? 98. And one of the numbers should be a perfect square. So now 49 is a perfect square, so we are free to go. Now this can be expressed as root of 49 times root of what? 2. Are you with me? Very good. So let's continue with life or with process. Now have it in mind that mathematically we said that root of 49 can be rewritten as root of 7 what squared. Now root 7 squared is the same as what? 49. Sorry, 7 squared is the same as 49 because 7 squared over here is 7 times what? 7. And 7 times 7 gives me what? 49. So that is why I've written it like that. So I have 49 as 7 squared. Now I have it in mind that this can also be expressed as 7 squared with the power of half. That is when the radical sign goes away. Remember that in mathematics, if I have root a, if I have root of a, this is the same as root a exponent what? Half. Are you with me? Or in other words, this has a power of 1. So this can be rewritten as a power 1 or in a bracket what? 1 out of that. So this is the same as what we have over there. So that is why we have this. Remember here the power is 2. So if assuming it's supposed to be a squared, so this should have been written as a power 2 or power half. Are you with me? Yes. Any number under the radical sign can be expressed as what? The number power half. That's what we have over here. Very good. So here, this one will cancel, leaving 7 power 1. Are you with me? Very good. So here it is termed as we have 2 multiplying 1 out of 2. And this is a whole number here, so it is over 1. Are you with me? So when we multiply 2 times 1, we are getting 2 over 1 times 2, where we are getting 2. And this is the same as, which is giving us 1 here. That is why we had power 1. Is it clear? Good. So here, we are getting the 49 to be 7, multiplying. Now root 2. Root 2 is the same as root 2 over there. Are you with me? Very good. So root 2 is the same as that we have over there. Because the reason is, when we have root 2, do we have any number power 2 that will give us 2? No, there's nothing like that. We don't have any number power 2 that will give us 2. Do we have any number exponent positive 2 that will give us? No, it is not possible, right? So we maintain it as it is like that. Now, in one of the rules of surd, when we are multiplying a whole number and a surd, we cannot multiply the 7 times the 2 here, no, because this is a whole number and this is what? A radical number. So here there's a whole number that is in front of the 2, so we use the 7 to multiply the 1. Are you getting me? Because here there's a coefficient. There is a coefficient, so we use the 7 to multiply the 1, where we are getting 7 root of 1, 2. Are you getting me? So this becomes our final answer. So we are getting this as our answer. I believe it is clear. Very good. Or in other words, you can also say that from here, if you are getting, let's say, 7 times root of 2, you can say let let x be equal to root of 2. So now, because we all know how to solve algebra, now that we are saying let x be equal to root 2, so wherever I see root 2, I substitute x. Now, we all understand what's meant by algebra. Algebraically, when we multiply 7 times x, we are going to get what? 7x. Then after we substitute root 2 in place of x, where we are going to get what? 7 root of x. So you see, it's the same as what we have here. It's the same as what we have over here. I believe it is clear. Very good. So let's solve the last question, which is question number 3. I said I'm solving question number 1 and 3 with you. Then after you solve the rest on your own. Very good. So let's continue with the process. That's the last question. Question number 3. Question number 3. I have root of 1764. And that is what I have over here. So this one I will expand this big radical sign, come to the top. So here too, I'll pick one of the perfect squares and I will use to work. The same, and if I pick one, it will be the same as the number itself. So let me pick 4 and see with the help of the long division. Now, how many times does the 4 goes into 1764? How many times does it go into? 4 goes into 17. How many times? It goes into it 4 times, so I have 16. 16 here, remainder 1. So I'll add the 6 to it, making it what? 16. 4 goes into 16 4 times. I have 16, remainder of what? 0, 0. I'll bring the 4 down. It goes into it 1. So I'm getting 1 here. I get it. Very good. So over here, it means that 4 can go into that. So I have 4 multiplying 4, 4, 1. So that's what I'm getting. So let's see what happens next in mathematics. So here, it is the same as root of 4 multiplying root of 4, 4, 1. Are you with me? Very good. Now we know that root 4 is the same as what? Root 4 can be rewritten as root of 2 squared. And this can be rewritten as 2 power half. Where over here the 2 here will cancel, leaving behind 2 power what? 1. I explained this earlier, so I believe you get it. Very good. So this one gives us 2 multiplying 2 power 1. 2 power 1 is the same as the 2 that we have over here. Very good. Now, can we still decompose this? Can we still have 2 numbers that when you multiply get 441? So let's see. Let me use any of the perfect square to check it and see if it will work. Is it possible? Let's check it and see. Let's use 9 and see if 9 can divide this one as we have over there. So 4, 4, 1. 9 goes into, first of all, let's say 4 times. 4, 9, 36, leaving behind 8. So we bring the 1. We have 9 here. So it means that for over here, I can get 9 times 49. And 9 times 49, let's see if we are going to get 4, 4, 1. So 49 times 9. 9, 9, 81. So 1, remainder of 8. 9 times 4, which is what? 36 plus 8, which is what? 44. So it means that it is true. Good. So here, mathematically, I can express this whole thing as 2 times root of 9 multiplying root of 49. Are you with me? Very good. So let's continue with the process. Now, root 9 can be rewritten as 3 squared that. And this is the same as 3 power 2 or power what? Half. Okay, and this the 2 will cancel, where I'm going to get what? 3. I believe it is clear. So this gives me 2 times 3 multiplying the same, and if I have root of 49, the same as root of 7 squared. 7 squared is the same as 49. So here I have 7 power 2 or power half. So here it will cancel out, giving me 7. So I'm going to get what, 7 over here. So here I multiply, because I have whole numbers throughout, I just multiply the whole numbers, then I will move on with life. So I'm now having with the continuation, I have 2 times 3 multiplying 7. So here I am going to multiply it by 3 times. That's where I'm going to get what, 42. So 42 becomes my answer. 42 becomes that. Are you with me? Very good. So that is what I'm getting. So my answer becomes what? 42. Please have it in mind, it is not always that you get a whole number. Remember the number one that we solved, we had 7 root what? 2. If you could remember the answer that we had 7 root 2. This one we are getting 42. So it is not anything difficult. You have to always make sure that you open your mind a little bit and know how to use the perfect squares to work along with any of the numbers. Now I told you that before you can decompose this, have it in mind that you get 2, 3 numbers that when you multiply, you will get what the number given. And have it in mind one of the numbers should be a perfect square. Likewise, if you follow the trick that I have done over here, it will help you to solve the question easily. Have a wonderful day. If you have any question, please bring it within the comment section. And please, if you like this video and you want to be the first person to see any video like this or more update on this, then please make sure that after watching you like and then you subscribe. Thank you very much for your cooperation. I'll have a wonderful day. Bye bye.